Approaching 130 participants, so let's start, and colleagues will join, I think, in the next few minutes before Raphael starts. So let me put my camera on as well, and let's begin. I hope you can all hear me well. Raphael, can you hear me?
Yes.
Great. Okay, let's begin. So hello everyone, and welcome to this third webinar in UNICEF's webinar series on data collection, which is organized by the Data and Analytics section at UNICEF headquarters. I'm Atilla Hancıoğlu, Chief of Data Collection Unit in the Data and Analytics section in UNICEF headquarters. We did 2 webinars last week. Many of you were probably on those webinars as well. Those were on social media advertising data and telephone surveys using IVR and SMS, both of which are now available on our SharePoint site. You can find a link to that site in the announcement email that you received. And today's webinar will also be uploaded to SharePoint. Our webinar today is on coverage and sampling issues in telephone surveys. I would first like to thank our speaker, Raphael Nishimura, for agreeing to present in our webinar series, not only today, but also next week, which will be a continuation of the same topic of telephone surveys. This time, we will focus on non-response and waiting issues. I probably do not need to emphasize the growing importance of this topic in UNICEF, as we have seen an exponential increase in UNICEF's support to telephone surveys in the last few months since the beginning of the COVID pandemic. I'm sure that today's and next week's webinars will be very useful in answering several questions in our minds on telephone surveys. Our speaker, Raphael Nishimura, today is the Director of Sampling Operations in the Survey Research Operations of the Survey Research Center at the Institute of Social Research, University of Michigan. Raphael has been working on sampling and survey statistics for over 10 years. He holds a PhD in survey methodology from the University of Michigan and a bachelor's degree in statistics from the University of Sao Paulo. His main research interests include sampling methods, survey non-response, and adaptive responsive designs. Raphael is also the director of the sampling program for survey statisticians of the Summers Institute for Survey Research Techniques, University of Michigan. Raphael will aim to finish his presentation in 40-45 minutes, after which we will start the Q&A. Throughout the webinar, please remain muted. Please write your questions in the chat box. Raphael will have a chance to answer your questions as time permits. I and my colleagues will group your questions and direct them to Raphael during the Q&A. So Raphael, please share your screen. The floor is all yours now.
Thank you, Attila. Can you see my screen?
Yes.
Okay, great. Well, good morning, good afternoon, good evening, everyone. I like to use this introduction on these days, like for a couple of reasons, right? Like I see on the chat, there are people all over the globe. That's great. So people in different time zones. I also like to use this to always remember that movie, The Truman Show, I believe. And I think it reflects very well our current situation these days. So thank you for the introduction, Attila. I see some familiar faces here on the chat, so I'm very glad that you guys, despite knowing me and knowing like a little bit of what I'm going to talk today, you were willing to use some of your hours today to attend this webinar. And thank you everyone else also to attending the webinar today. So this presentation that I'm going to give today, I gave a very similar presentation back in May to UN ECHA. So just wanted to acknowledge that. If anyone here attended that presentation, you're probably going to see something very similar to what I presented back then. And if you didn't, great. Hopefully you're going to see something new here. So as Attila said, I'm going to talk about coverage and sampling considerations in telephone surveys. especially thinking, as probably it's the case for many of you, when transitioning, right, like from face-to-face to telephone surveys, what to consider, what are the differences, what are the issues, but of course here the focus is telephone surveys. So I'm going to start with, oh, there you go. I'm going to start with just like a few concepts in survey statistics that probably a lot of you already know, but in case you don't know, like we start all on the same point. So first, I'd like to start talking about this concept of sampling frames, because it is a very important concept when talking about coverage in surveys, right? So what is a sampling frame? Sampling frame is usually a set of materials, or it could be also a set of procedures that are used to identify and select units and elements from population, right? So it is those sampling frames can be things like lists, right? Like that's probably the simplest example of sampling frame material. You would like to select elements from a certain population, like members of a professional organization or establishments, schools, hospitals, even population or households. If you have a list of those elements, right? Like that would be a sampling frame that you could use to not only identify those population elements, but also select those to your sample. Now, in many cases, as many of you might know, we don't have access, depending on the population, depending on the context, depending on the country, you don't have a list, a sampling frame of those population elements. So we have to build further materials to somehow have access to those population elements. So another set of materials that are usually used as a sampling frame are things like maps. This is specifically, or especially, I should say, useful in face-to-face surveys, where you use some sort of area probability sampling, that through a sequence of sampling stages, right? Like you select your sample, a sequence of selections of geographical areas, right? You start with a larger area, say like something like a city or a village or a county. Then within those selected units, right? Within those selected cities, counties, villages, you select a sample of blocks, of segments. Some countries use the idea of enumeration areas, right? And within those, you select a sample of, say, households and persons. So for that kind of selection, for that kind of sampling, maps are very useful sampling frames. But sampling frames can also be certain procedures, right? And we're going to talk a little bit about that later today when I talk about a random digit dialing, or as many of you might have heard, RDD. This is a procedure that is commonly used in telephone surveys to generate a sample of telephone numbers by generating random telephone numbers. We're going to talk about that. But anyhow, this is the idea of sampling frames. As I said, face-to-face data collections usually rely on sample designs commonly known as area probability sampling that rely on sampling techniques such as clustering, right? So this idea of you're going to select cluster of elements. In our case, usually these clusters of elements are things like cities, villages, counties, then could also be segments, city blocks, enumeration areas, right? So, and face-to-face data collection usually rely on those to reduce survey costs, right? It comes with also with a statistical cost that it tends to increase the sampling variance or decrease the precision of the estimates, but it reduces survey costs. And for those, as I said, lists and maps of geographical areas are very commonly used as frames in a technique that I've been mentioning before, and I'm sure that a lot of you are familiar, called area probability sampling, right? Now, telephone data collection, telephone surveys, generally we don't need clustering because there is not much of a cost to select a sample over widespread geographical area, right? Like the idea of using clustering on face-to-face data collection is because especially travel costs, sending interviewers to the field to certain locations tends to be relatively expensive. With telephone surveys, we don't have that sort of problem because the cost of calling different telephone numbers across a pretty wide spread sample, geographically speaking, is not that relevant here. But you need to think about on how to create sampling frames for telephone surveys, right? So there are like 2 or 3 options usually that people usually consider for telephone surveys. And I'm sure that some of you that have been involved with transitioning, right, from maybe a face-to-face survey to a telephone survey has been considering and have probably been using. So one of those is if you have previously collected a survey and you usually a face-to-face survey, and you have collected on that survey a telephone number, you can use that sample as like a sampling frame, right, to a telephone survey, a telephone data collection. This is something that I know, for example, I've been talking to Attila, like I know that like in some of the Mix projects or Mix Plus, I have been using or considering to use that. I've been involved consulting for a project in Brazil, one of their largest or their largest household survey, in which they have collected previously a very high quality household probability sample survey, and they were able to, for part of that survey, for part of that sample, they were able to collect telephone numbers, and for another part, they were able to append telephone numbers using different databases. And now they are using that like very high quality face-to-face survey as a frame with the telephone numbers that were appended or collected to that to now collect information through telephone survey. So that's definitely one option if you have this previously collected survey in which you either collected the telephone numbers or you were able to append telephone numbers. Now, that's not always the case, right? So another very common option that a lot of people consider is to use telephone numbers from telephone directories or lists of telephone numbers from telecommunication companies, right? I'm going to talk a little bit about that. That is a very efficient way to select telephone numbers, because that falls under that idea that you have a list now, a sampling frame that is a list of the elements that you wish to select, right? In this case here, telephone numbers. And in most cases, a lot of those numbers are active numbers. So you don't have certain inefficiencies in your data collection of maybe calling a lot of telephone numbers that are invalid, that don't exist, right? However, there are also several disadvantages with this approach, especially talking about coverage, which I'm going to cover, which I'm going to discuss in a little bit, because a lot of the times, this telephone directories or these lists of telephone numbers don't cover every telephone number in your target population. And now like you have this coverage issue, which I'm going to address in a second. And finally, random digit dialing, another way to create sampling frames, which I'm going to address towards the end of my presentation. So sampling frames, right? Now, this idea of sampling frames is important to talk about coverage error, right? Like, and that's one of the considerations here that I would like to address on my presentation today. So what is coverage error? So And I promise this is going to be the only slide that I'm going to have some sort of like statistical mathematical notation. Okay, so bear with me here. After this, like you won't need to see, at least not today, any mathematical formulas or anything like that. All right. So let's assume that you have a target population represented here by this rectangular image here and this population is of size capital N. That's what usually the notation that we use in sampling to denote the population size. And you want to estimate a certain parameter of this population, a certain, say, average, a certain mean, denoted here by Y bar, capital Y bar. Okay. Now, in order to select a sample from this target population, you're going to use a sampling frame, right? Now, sampling frames in general have certain deficiencies. And I'm going to discuss a little bit of those deficiencies. So you see that now the sampling frame is represented by this yellow rectangular here, rectangle, and you see that it doesn't fully cover the target population, and there is like this part of the sampling frame that is actually a little bit outside the target population. So let's talk a little bit about both these problems, right? So first problem here is this part of the sampling frame, right, that cover elements that don't actually belong to our target population. I'm going to give a couple of examples in my next slide about like why this could happen, especially in the context of telephone sampling. But that is like usually that's a problem that can sometimes happen, especially, for example, say a very typical example, already giving an example here, is your target population is not the general population, right? Like say a general population 18 plus, right? Maybe you're interested, maybe in a fertility survey, you're interested only in people between 18 to 49 years old, right? So, but even with area probability sampling, right? Like you typically have some sort of overcoverage because when you select your sample, you will select very likely, right? Like households that only have people over that age threshold, over the age of 49 years old or 50 years old, right? So you have like some overcoverage. That is, there are elements in your sampling frame that don't belong to your target population. Now, this is not necessarily a problem in terms of bias, because during data collection, you should be able to identify those elements that do not belong to our target population, and you'll be able to screen them out, right? So you'll be able to remove them from your sample. The issue that this causes is that it decreases the efficiency of your sample, right? You're gonna have to select more cases in your sample to be able to get your target sample size. But apart from that, it doesn't really cause any biases in your estimates in general. So now, what's the other problem? The other side of the problem of deficiencies in sampling frame is this area here of the target population that your frame doesn't cover, right? Like your frame is not able to capture. This is what we call undercoverage. And that will be the main source of concern with in coverage error, not being able to cover certain elements in your population on your frame. And this can cause bias. And so here's the formula that I told you that is going to pop up here. Promise is the only one. And the bias on, say, like a sample mean due to this issue here, not being able to cover every element in the population, is given by this expression here. So let me just explain a little bit some of these elements here. So first, I'm denoting by capital NC the size of the population that is covered by your frame, right? So like this like part of the population here that your sampling frame covers. And capital Y bar sub C by the population mean of that part of the population. Okay, so say that you want to estimate, I don't know, average income. That would be the average income of the elements that are covered in your by your sampling frame. Then capital N sub NC is the size of the population that is not covered by your sampling frame, and capital Y bar sub NC is the population average, population mean on that outcome of interest from the elements that are not covered by that frame, right? So if you take now these elements, the bias of a sample mean due to this undercoverage problem is given by this expression here. And this expression have two components. The first component is this ratio here, which is essentially an undercoverage rate, is the proportion in your population of elements that are not covered by your frame, right? So is this capital N sub NC divided by your population size, capital N. This can also be denoted as the complement, 1 minus the coverage rate, 1 minus the proportion of your population that is covered by your frame, okay? Then the second component of this bias is the difference between the covered and the non-covered populations in terms of whatever you're measuring. So in my example here, I was saying, say that we're interested in estimating the average income. So that would be the difference between the covered and the non-covered population on that income variable, right? So you see that there are two important components that address coverage bias, right? Fortunately, we usually can estimate this first one here, usually using external data, external surveys or censuses. The second component here, it's sometimes more difficult to estimate. You would need either very special studies or again, like access to external data, which will typically not be as easily to be found as that first component here. And on top of that, this, as you see here, will be variable specific. This depends on what variable you're measuring, in the sense that now, even for a given coverage rate, right, say that you are able to cover X% of your population, different variables in your survey might have different level of coverage bias or under coverage bias. Okay, so let me give an example here to maybe make things a little bit more like real, right? So here I'm showing 4 different scenarios in which I changed a little bit those two components. First, that under coverage rate, the proportion of the population that is not covered by your frame, and the difference between the covered and the non-covered population. So let's assume here that I'm trying to estimate average monthly income, household income, right? That's my Y variable on this example. And on this first example, on this first scenario, I'm assuming that my frame does not cover the under coverage rate 10% of the population, or alternatively, it covers 90% of the population. So it's a pretty good coverage rate on this example. And let's assume that now the average income for the population that is covered is $2,750, and the average income for the population that is not covered is $2,250. So that difference between these two groups here in terms of their average income is $500. So if we put those pieces together now, like this under coverage rate and this difference here, the bias of a sample mean for this scenario would be like $50. Okay, so that's first scenario. Let's compare with another scenario in which you still have another coverage rate of 10%. So your population, you're not able to capture 10% of your population by your frame, or you captured 90% of your population. But now there's a much larger difference, right? Like the covered population is much wealthier than the not covered population, right? So the difference here now between the two groups is $4,000. You see that with the same under coverage rate, but with a much larger difference, you have a much larger bias in your sample mean, all right? Okay, so, and this is, again, assuming the same under coverage rate. Now let's see a third scenario to make it a little bit more interesting. Let's assume now that you have a much higher under coverage rate. You are not able to capture 60% of your population. That's like pretty bad, right? Your sampling frame only is able to cover 40% of the population. Even when the difference between these two groups is not that large, right? No, sorry. When let me first start with, when the difference between the two groups is not that large, right? Like it's, again, the same difference of that first scenario here, your bias is still smaller than like the second scenario here, in which you have a relatively small under coverage rate with a very large difference, right? It is definitely much larger than that first scenario in which the difference is the same as this third scenario here, right? But the under coverage rate is much higher. But it's interestingly, right? It is still smaller than the scenario in which you have a much smaller under coverage rate, but a very large difference between the two groups, right? And finally, just for completion here, fourth scenario in which you have a very high under coverage rate, 60%, and also a very large difference between the two groups, $4,000. You see that now the bias is like extremely large, much larger than the previous three scenarios. So this is just to exemplify that when thinking about coverage, you have to think about two components. One, what is the proportion of my population that is not covered by your frame, right? Usually this you can estimate a lot of the times. I'm going to show a few examples on how. But the second component is what is the difference between the two groups in terms of your survey variable or survey variables, right? And as I said before, this difference typically is very hard to estimate. Like you typically don't have data to estimate that, because if you did, you probably wouldn't be conducting your survey to begin with. You may, for example, estimate that using certain social demographic variables. But what is really important is what's the difference between these two groups in terms of your outcome of interest, in terms of your survey variables, right? And another important observation here is that this will vary from variable to variable. So even within a survey of a certain under coverage rate, say this 10% here, right? Two variables in your survey or multiple variables in your survey with different differences between the covered and the uncovered population can have different level of biases, right? So it's also sometimes very hard to access this kind of bias. But it is important to have this in mind when considering different sampling frames, different modes of data collection, so that you have an idea of what is the potential bias in your estimates due to this undercoverage error. So now let's put this in context now of this face-to-face and telephone surveys, right? So as I said before, probably a lot of you were using or are using some sort of area probability sampling, and you're using for that an area frame, right? A set of like lists and maps of geographical areas that you're going to use to select sample through a sequence of sampling stages, right? Usually area frames for face-to-face data collection, and for household surveys and general population surveys, they tend to be considered like kind of like a gold standard, because as long as there is a one-to-one correspondence between elements, people, or households to geographical areas, right? And as long as your sampling frame materials, your set of sampling frame materials are able to cover the entire area of your target population, the coverage rate tends to be like, in theory, 100%, or in practice, something very close to 100%. So you see here that on my representation here, the sampling frame covers almost the entire population. Of course, like we know that in practice, there are some deficiencies sometimes, like there can be issues with the sampling frame, the materials they're using for an area probability sampling. So to really say like it's 100%, like it might be a very strong argument. So very close to 100%. So it's a gold standard. Now let's compare that with a telephone frame that you would use for telephone surveys, right? So with telephone surveys, I'm assuming here that you are interested in like a household survey or a general population survey, right? So you're calling numbers to reach a household. You're calling numbers to reach a person, right? And with telephone frames, the issue here is that first, here you have your target population, and let's say that you're interested in a household survey. Not every household may have access to a telephone number, right? To a telephone device. So your telephone frame will only cover those households with a telephone access, right? And you'll be missing out. You're going to have an undercoverage error there of the households without a telephone, right? And now, as long as you have estimates from your population of what is the telephone penetration in that population, you can estimate more or less what's the coverage rate, right? Like on telephone surveys, especially if you use something like an RDD procedure, right? Like if you're talking about like a list, a telephone directory, or a list of telephone numbers, you're gonna have to make special considerations about that. But if you use like a procedure that is able to almost guarantee that every telephone number can be selected, right? The coverage rate for that sort of frame tends to be very close to the telephone penetration under that population, right? I'm going to show also a few examples on that. So that's the under coverage part here. But telephone surveys also have an over coverage issue here that, again, will not cause necessarily bias, but it will decrease the efficiency of your sample, in the sense that you're going to be calling telephone numbers that do not actually belong to our target population. So what are those numbers? A lot of times, when you generate this kind of samples, you're going to generate a pretty large amount of non-working or inactive telephone numbers. Again, like it's not going to be an issue, because you should be able to quickly identify that that's not a working number, that is like an inactive number, and you just screen out your sample. But it's time that is spent, right, like calling that number, especially if you're having interviewers manually dialing the number. That can be like quite costly, having to go through a pretty large number of telephones that are not inactive. Other examples are things like business numbers, government numbers. Those are also telephone numbers that don't belong to your household population, but you're able to quickly identify those and screen them out, remove them from your survey, your sample. Okay, so what are certain considerations to have between face-to-face and phone surveys, right? So first, when transitioning from face-to-face to phone, first thing to consider is, as I was mentioning before, what's the telephone penetration in your target population in terms of households and or individuals. So that's that first component of the bias, right? Like if you have a high telephone penetration, that's great. Your bias will tend to be on average like smaller than if your telephone penetration in your population is lower. But the other component to consider, what are the differences between the populations with and without telephone access, right? Now, this will vary from country to country, from even within country, right, will vary. But what we know from previous research is that there are certain differences in terms of urbanicity. In general, urban areas tends to have, in general, population with telephone access tends to be more urban. Wealth, in general, again, on average, population with telephone access tends to be somehow wealthier. Age, it varies from country to country, but like in some countries, you know that in some countries, younger people have a high telephone penetration. Some other countries, older populations have. In some countries, there's a gender gap. So in some countries, like females have a lower telephone penetration than like males. So these are things also that you should consider when using a telephone survey. Overcoverage, as I said before, is another issue with telephone surveys, in the sense that in general, there is, depending on how you select your sample, there can be a large proportion of numbers that are non-working or inactive. And here's a special observation. If using lists or telephone directories, lists of telephone numbers or telephone directories, you really need to consider what is the coverage properties of these lists and directories, because in general, such lists and telephone directories, they will not cover every possible telephone number. So you really need to consider what are also the percentage of telephone numbers that those lists or directories are covering, because that will add to that undercoverage issue. And finally, households that are in those lists and directories, the telephone numbers from households that are on those lists and directories tend to be, especially depending on what is the source of those telephone directories, tends to be different from households with telephone access, but they are not listed in those telephone directories. And this, as I said, can lead to some undercoverage biases. I'm getting here some questions, which I'm hoping to address, I think, on the Q&A session. Okay, so just wanted to mention that. So now, another thing to consider with telephone surveys is we have two types of devices in generally speaking, right? Landline telephone numbers and cell phone telephone numbers, right? And telephone surveys leads to this kind of special problem in sampling, because if you're sampling, so you can consider now that you have two frames of telephone numbers. One frame is a frame of landline telephone numbers, and another frame is a frame of cell phone telephone numbers, right? And telephone sampling is kind of have this special problem, because if you're using both frames, right, you're gonna capture, right, like households that only have landline telephone numbers. They only have landlines but don't have cell phones. This is what we call landline only. I know these days this is a very small percentage in general of the population, but they still exist in a lot of countries. The other side of that coin is households that only have access to cell phone numbers. This tends to be a very large proportion in general in a lot of countries of the population. But you have also this intersection, this overlap of the frames of the population that have both access to landline and cell phone numbers. And when you're using this kind of design, this kind of like sampling in which you're selecting both landlines and cell phone numbers, these people here in the middle, right, what we call dual users, they would tend to have a higher probability of selection than those who only have access to landline or only have access to cell phones. And there are a couple of ways to address this sort of issue. The first way is using an overlapping design, in the sense that you're going to select a sample of landlines, a sample of cell phones, and you're going to allow to have in your sample cases, respondents that are landline only, respondents that are cell phone only, and dual user respondents. And then you're going to address this issue, the selection probability issue here on weighting. I'm going to talk a little bit about that in our next slide. Another alternative to deal with this problem is through a screening design. What is a screening design? Screening design is you're going to select a sample of landline numbers, right? And you're going to interview in your sample both respondents that are landline only and dual users on that part of the sample, on the landline part of the sample. On the cell phone part of the sample, you are going to interview only respondents that are cell phone only. If you capture on that cell phone sample dual users, you're going to screen them out. You're not going to interview them. It might sound a little bit inefficient, and it is, right? But by doing that, you eliminate that sort of like differential selection probability that I was referring to by only selecting dual users from one or another frame, right? In my example here, I use landline as the frame that you're going to select the dual users. You're going to interview the dual users, and the cell phones that you're going to screen out, but could be the other way around, okay? So you have to consider, there are a couple of considerations here when talking about landline and cell phone numbers. This dual, by the way, I should have said, this overlapping design here is also referred to dual frame designs, okay? So these dual frame designs, both of them are dual frame designs. This is an overlapping design. Let me just like talk to this dual kind of frame designs tends to have better coverage than an alternative that I'm going to mention next. but needs to address these dual users problems. One way, as I was saying, is to allow overlapping design, and you need to account for this differential selection probabilities through weighting, which I'm hoping to cover on my next webinar. And the screening design, or another alternative is the screening design. It's less efficient because you need to screen out a large portion of the respondents sometimes, but you don't have to deal with this weighting issue. Another alternative is to actually consider, in many countries, in many countries they're considering that a cell-only design. What is a cell-only design? It's a design in which you're only going to select a sample from the cell frame. This is an advantage of that of this kind of design is that it avoids the inefficiencies of screening design and complications of weighting of dual users in overlapping designs that is due to this dual frame design. But there is, of course, a potential for coverage bias, like a further potential of coverage bias, other than what you typically have on telephone surveys. So this, in general, has a lower coverage rate. And I would only really consider this kind of design here, depending on what's the cell phone coverage on your target population. So for that, I'm just going to show here an example of what is the cell phone coverage on different countries here. This data is coming from the Afrobarometer, round 7. So thank you for my colleagues of the Afrobarometer for sharing that with us. And you see here, like the different countries, like in Middle Eastern and North Africa, have like different cell phone coverage rates, right? And honestly, I will be more comfortable using a cell phone only design in these countries that have like a higher cell phone coverage, say like above 90 or close to 90% cell phone coverage penetration. I would probably think more carefully on these countries here in the middle that have like a cell phone rate between, say, 75 to 90%. I would probably think on like, okay, what are the differences between this population that have a cell phone device and those that don't? And these countries here in the lower side, like with cell phone coverage rate like lower than, say, like 80, 75 or 80%, I would probably discourage them to use like a cell phone only design. Again, this is only cell phone numbers, because there is a higher potential for coverage bias here. Then I have like this other data here, cell phone coverage that either the person owns that phone personally or someone in the household owns. So like in a way, like this is a household cell phone coverage, right? And you see that the picture here looks a little bit better. More countries have like coverage, a cell phone rate, penetration rate like higher than 90%. Some countries here has that like between like 80 to 75, 80 to 90%. Those again, I would think a little bit more before considering such a design. And there's still at least like a few countries here on the right-hand side that still have a pretty lower, considerably lower cell phone rate, even considering household ownership, which I'll probably discourage them from using cell-only design. Anyhow, well, some other considerations, again, with landline and cell phone numbers. If you are selecting landline numbers, those tend to be considered household devices, right? So like if you call a landline number, you consider that everyone in the household was kind of like selected. And if you need to do some sort of like person interview, you would have to conduct some sort of like within household listing and selection. In some surveys, they do that by just selecting whoever answered the phone, but this may lead to some selection bias. You can just think about like your own household surveys, right? Like if you only interview whoever is at home at that time, right? Like you may have certain biases because maybe depending on the time that you're visiting the house or the time you're calling the house, some people tends to be more likely to be on the household than others. Some other surveys consider, instead of this whoever answers the phone approach, some sort of like either random selection. So a lot of you are familiar with something like a quiche table or a quiche grid, or other pseudo-random within household selection procedure, such as next and last birthday. Who in the household has the next birthday or has the last birthday, and that person selected. With cell phone numbers, those generally are assumed to be individual devices. That is, if you call a cell phone number, whoever answers that phone is assumed to be the owner of that phone, and therefore the person who is selected for a survey. So no within a household listing and selection is needed. But if a shared cell phone in the household is widespread in the population, you may consider to assume that cell phone devices are household devices and do some sort of within household selection. There's also the issue of multiplicity. I'm not going to address here a lot, but something that you definitely need to consider, especially in waiting. I'm going to talk more about that on my next webinar. Individuals with more than one telephone number, whether a landline or a cell phone, will have higher chance of being selected than those that only have one or few numbers. This needs to be addressed through waiting. And you need to collect that sort of information. You need to collect how many telephone numbers those individuals have in order to address that in the waiting. Okay, so this was coverage, right? What am I doing in terms of time? Oh gosh, I am. For those who know me, you know that I talk a lot, right? And of course that this happens. I have just a few slides on sampling. They're pretty chunky, but I'm gonna try to go through them reasonably quickly, but not as quick that you're not going to understand, but to give at least half an hour, 25 or 20 minutes of questions here. So telephone sampling for telephone surveys. What I'm going to talk about here today is I'm going to focus on this random digit dialing procedure, because that's for telephone surveys considered to be the gold standard. Okay, and also like with if you're either using a previously selected sample with telephone numbers that were collected or appended, or if you're using a list of telephone numbers or a directory of telephone numbers, sampling there is fairly straightforward. So I'm not gonna address that. Now, with random digit dialing, one very important message that I usually try to convey when I talk about that is that a very important thing to know is the knowledge of how telephone systems work in your country. What I mean by that? Generally, what I mean by that is how telephone numbers are assigned to users in the country or in the area we're doing the study. And you're going to see why this is so important, especially to try to increase the efficiency of this kind of sample. But the idea here of telephones or random digit dialing is fairly simple. What we're going to do is to literally randomly generate digits on a telephone number in appropriate sequences. Now, this appropriate sequence is very important, right? Because again, this is part of the knowledge of the telephone system. We know that not every combination of digits will make sense for a telephone number, right? For example, in a country like here in the US that have numbers, right, like here of 10 digits, 3 area codes, 3 prefixes, and 4 suffixes. Doesn't make sense to generate a telephone number that only has 8 digits or 7 digits, right? Like we're only going to generate numbers with 10 digits. A part of that, in a lot of countries, you also may have the information that only certain sequences of numbers are valid numbers, right? And you're going to restrict the generation of the digits for telephone numbers on those sequences. Another important consideration, another important knowledge to have is, are there correspondences between areas, geographical areas, and certain area codes of telephone numbers, or prefix or area code and prefix combinations, right? If there is such correspondence, you may use that either if you need to select a sample only on a certain area. You're going to use that to restrict the generation of your telephone numbers on those areas, or to use for something like stratification. You'd like to stratify your sample by geography. And as long as you have that knowledge of, okay, so these combinations of area codes or these area codes and combinations of area codes and prefixes are on these certain areas, you can use that to generate a stratified random sample. And so this is what I'm pretty much saying here, right? Like the selection of area code prefixes can be used to employ certification. This typically tends to be more straightforward with landline numbers, because landline numbers, by definition, they are located on a certain they are in a certain location, right, in a certain area. This is a little bit more difficult with cell phone numbers because people move, right? A lot of the times we don't have very clear correspondence between area and phone number with cell phone numbers, and also because of portability, right? Like you may get a telephone number in a certain area, then you can change your operator, your provider, you keep that number, you change area, so it's kind of a mess. You can also use sometimes the information of how telephone numbers are assigned to define like which numbers are residential, which sequence of numbers are residential, which sequence of numbers are commercial. Okay, but anyhow, like how do you generate a RDD sample? Literally, as long having this knowledge of what sequence of numbers are valid numbers, what sequence of area codes or prefixes are associated to certain geographical areas, you're going to literally generate random numbers for the digits. So here in the US, for example, we have the numbers work this way, right? 3 area codes followed by 3 digits prefix and a 4-digit suffix. We know that not every combination of 3 digits here leads to a valid area code. So we were only going to work within those area codes that we know would exist. And we know also that not every prefix within every area codes are valid. We're only going to work with prefixes that are valid. But apart from that, this, especially the suffix number here, they tend to be like they tend to be valid for most of the sequences. So we would generate this 4 last digits here purely randomly without any like restriction, any considerations. Now, as you may expect, this will lead to very inefficient samples, in the sense that most of the telephone numbers that are generated will tend to be invalid, non-working, or inactive, right? So you're going to be generating a very large, you can generate, in theory, very cheaply, a very large sample of telephone numbers randomly, but your inefficiencies will come on during data collection, in which you're going to have interviewers calling those numbers, and for a lot of those, they are not going to be valid, just because like they were randomly generated without necessarily considering whether those numbers are working or not, because we don't have in most of the cases the information whether a telephone number is valid or not. It's even if we are only working under valid area codes and valid prefixes. Okay, there's still a lot of potential numbers there that can be generated within valid area codes and prefixes that might be invalid. So in order to improve the efficiency of this pure RDD samples, 2 very smart statisticians back in the 60s, I want to say, Mitofsky and Waxberg, developed this procedure to try to improve the efficiency of the sample. The idea here is a 2-stage selection of random digit dialing numbers. So it's kind of like a cluster sample for those who are familiar with this concept. In that first stage, what they do is they select RDD sample, what they call like a sample of primary numbers, like a random number, a random sample of telephone numbers using that procedure that I described before, right? Then the interviewers are going to dial those primary numbers, and they're going to determine whether that number is residential or not, assuming that's a household survey or general population survey. They're going to determine the residential status. If that number is residential, they're going to define a cluster of 100 consecutive numbers that telephone number belong to, right? So what I mean by 100 consecutive numbers, they will be numbers that have the same area code on the US context, the same prefix, the same first 2 digits suffix, and then you're gonna work with a sequence of telephone numbers going from that number 00 and like that number 99. So you see that on the sequence now we have 100 consecutive numbers, in which this sequence is that number that the interviewer called, right, belongs to the sequence, that number that the interviewer called and determined that was a residential number. Okay, so as like my example here, imagine that the primary number 999-555-0012 was dialed and confirmed residential. Then you're going to define as a 100 bank the following sequence of telephone numbers: 999-555-0000 and 999-555-0099. Why? Because this number here belongs to this bank. And what we're going to do in a second stage, what we're going to do is we're going to select a subsample of lowercase b numbers, with b being between 1 and 199, from this within working cluster, or from this 100 bank. And so the interviewers are going to dial this secondary numbers, so like the subsample of numbers within this bank, and determine the residential status. If it's not residential, they're going to discard and replace with a new number. And if the residential, they're going to interview, they're going to try to interview that number. And this second stage will proceed, will continue replacing numbers if they're not residential until we reach B residential numbers. Notice that if a number is residential, but you're not able, you have a non-response, you have a refusal, you're not going to replace it. You're only going to replace it if the number is not residential. Or if you cannot determine that number is residential or not, you're not going to replace it. Now, why does this procedure work? So this procedure works, at least here in the US context. It might not work very well in other countries. Again, because the way telephone numbers are assigned to users. First, because of the way telephone numbers are assigned to telephone companies, and the way telephone companies assign telephone numbers to users. Why? Because we know that telephone communications agencies assign telephone numbers to telephone companies by this blocks of numbers, right? They assign to those telephone companies, like, okay, you telephone company A, you get numbers on this range here. You telephone company B, you get numbers on this range. And then the telephone companies assign those numbers to their users, right? And so what does this mean? It means that if you call a number within a certain sequence and you identify that the number is valid, is residential, chances are that other numbers within that range are also valid. Again, because of the way the telephone system works here in the US. Now, this may not be true necessarily in every country, and that's something you're going to need to investigate in your own context to see if that's the way telephone numbers are assigned. I know, for example, I've been working in Brazil with some telephone surveys, and I know that that's the way also telephone numbers are assigned in Brazil as well. Okay, so that this procedure tends to work also in Brazil, for example. May not work in every other country, in every country. Okay, so last slide here. There are other ways to improve this RDD design, further improve than using this Waxberg-Minkowski method, usually using lists or telephone directories, right? So this is what we call list-assisted designs. One way is to first identify. So if you have a list of telephone numbers, right, or telephone directory, what you could do is you take that list or that telephone directory and identify those sequence of, identify which sequence of telephone numbers, which what I've been calling 100 banks, have a listed telephone number, right? Why? Because usually listed telephone numbers tends to be more likely to be active than not. And what you can do then is, after you identify those 100 banks that have listed numbers, there are certain things that you can do with those 100 banks that you identified having at least one telephone number. I'm going to talk a little bit about that now. Now, this kind of procedure is interesting because on one hand, it uses the efficiencies of the directories to overcome the RDD inefficiencies, in the sense that you are working with banks that can be more likely to have active numbers than others, and it avoids the non-coverage problems that these directories typically have. So what do you usually do with those listed, with those identification of 100 banks that have at least one listed number? One way is certification. You oversample these 100 numbers on these over 100 banks that are proportionally to the number of listed phone numbers using, like, for example, a technique called probability proportional to size. But you need to adjust this kind of oversampling using weights. This is a technique that I recently used in Brazil, and we're currently conducting the data collection over there. Another way is to use this idea of Oneplus block design, in which you only select telephone numbers from 100 banks that has at least one residential listed number. That is, like, you're only going to select telephone numbers from this sequence of telephone numbers that you were able to identify having at least one listed number. There's a modification of that called K plus design, in which you only select telephone numbers from 100 banks that have more than K or more, or K's 2 or more listed numbers. Now, these obviously have some undercoverage problems because telephone numbers in 100 banks with no listed numbers are not going to be covered on this design. So it's kind of like an efficiency coverage bias trade-off. And then finally, there is this other kind of approach of Oneplus Dialing. I'm not a very big fan of that, but the idea is to select telephone numbers using this directory listing, but instead of using the number that is on the list, you replace the last digit of the number by +1, or you can replace the last K digits with a random number. Now, this is not a probability sampling, so that's why I'm not a big fan. This can also have all sort of like non-coverage problems as well. So it's not like my own preferred alternative, but it is an alternative that some people use. Okay, so as I said, I talk a lot. I use way more than the time that was asked to me to talk here today. But I hopefully, I think we have 25 minutes or so, I can address some of your questions. Here's a list of references that are typically that I like to refer to telephone surveys. It doesn't only cover coverage and telephone sampling, cover other topics and telephone surveys. This will be available, I think, to you, so you can use that. Some of them are pretty old, back in the 2000s. Some other are more recent here, especially like this blog entry from the World Bank from my colleagues from RTI, actually, Charles Lau, who was here last week, I think wrote these entries. Very interesting, very good to take a look. And that's it. Here's my contact information if you're interested in discussing. If you have any other questions I'd like to address later. And yeah, I'm open for questions here.
Well, thank you so much, Raphael. This was an excellent presentation. Yes, we we use more than 45 minutes, but well worth it, obviously. And we do have something like 25 minutes. So I know that you have been glancing through some of the questions and comments coming in the chat box, but I don't expect you to have read all of them. Even I couldn't, because towards the end, they kept coming as bullets. Great questions and comments from colleagues. So if I may, while you look at the chat box yourself, I would like to go through some of them and direct them to you in order of how they came. But just to say that there's a number of comments and questions on non-response and waiting. Waiting in relation to bias, etc. Of course, these topics are not completely separable. And just to say, I leave it to you, of course, but I think for those specific comments and questions, we might think of next week's webinar where we will cover the waiting and non-response, and rather than spending time on them to address issues to do with coverage and sampling today.
Sure.
So There was a question about non-response in IVR, for instance. That's something for next week. There was an interesting question about using phone numbers from DHS and MIG surveys, which may have collected phone numbers, and going back to households with those phone numbers. What does it mean about in terms of violating data privacy agreements with the household? But also, I would like to extend that question to be a more general question, not only those phone numbers collected from during a DHS or mix, but also reaching out to households based on the phone numbers that we get from companies or from registration systems and others, because I think there are some issues, ethical issues that may be related to all of those, I would think.
Yeah, so that's a great question.
And then we can go to the other questions. Yeah.
Sure. Yeah, no, that's a great question. It is so when collecting that sort of information from previously selected surveys, I think that a very important lesson to have is whenever you collect those, to make sure that you include in your survey some sort of like clause or some sort of like a notification to the respondent that telephone number may be used later only for, right? Like, I think that's very important to reassure these respondents to contact them in a later point for maybe a future survey or something like that. I'm not an expert. I have like very good friends that are expert, that are much more knowledgeable in terms of like data privacy issues. I'm not an expert on that area, so I'm not going to also say necessarily anything about that. Like also with ethics, like it's not my area of expertise. I'm sure that there are some data privacy and ethical issues there that should be addressed. Since it's not like my area, I'm not going to comment much further than that. Other than, I completely agree with you, Attila, that not only like numbers that are previously selected in the survey, I mentioned, right? Like sometimes you can try to append telephone numbers to a sample. There probably have some ethical issues, some like data privacy issues there. Like I was mentioning, my I've been consulting for the National Statistical Office in Brazil. They were able to do that in a pretty large scale in one of their surveys for like this survey they are conducting since May, and over there the Supreme Court actually made a decision that they were not able to do that anymore, especially due to like privacy issues, right? So I'm sure, as I said, there are some things to consider there, but not my area of expertise, so I'm not going to make much comment on that. Many comments on that.
Thanks, Raphael. Maybe as a group of questions now. One is on, it is usually the case that we do not have any information or much information regarding the survey topic when it comes to those households or individuals which are outside the sample frame of, the phone coverage is not there. What can we do in these cases? Can we use RDD to target specific groups of populations? Is it possible? Is another question. Can you say something about the topics which are fit or unfit for, I would think this is about telephone surveys in general. Are there rules of thumb that we shouldn't be talking about certain things on the phone with respondents, for instance? What is fit and what is not fit? And finally, for this round of questions, there was a couple of comments on the U report that UNICEF has been supporting, which is an SMS-based initiative where respondents actually actively themselves register their phone numbers, and then they get poll questions and they respond to those poll questions. Not all of them, of course. There's response issues there too. There can be no response, in other words. Not everyone that registers their phone actually responds to the questions. This is important, and how do we think about this? So, is this representative at all? is some questions and some there was even some responses to that comment that I've seen.
Okay, good. So let me try. And let me know if I missed any of these questions that you asked right now. So the first one was related to whether in the country or in the area, like you don't have estimates on that penetration, telephone penetration rate, right? Like what you do. Yeah, that's a good question, right? So like as I was saying before, I assume that in a lot of places you would have either that sort of information through like official statistics survey or even census, but that might not be the case a lot of the times. And in those cases, what we do, and actually this is something that we do here in the US, we try to include that sort of question or information on high quality face-to-face surveys, like again, gold standard in terms of coverage, because then we use those surveys to have an estimate of that telephone penetration. Of course, that like now we cannot do that, or most of the places we cannot do that, like that sort of thing. Like we're not conducting face-to-face surveys right now, and if we don't have that, and we don't have any other source of information to get that estimate, I don't think there is a lot of other options, but it's definitely one lesson to learn from all of this, right? Like that when you're able to get back to conducting face-to-face surveys, maybe this is something that would be interesting to include in a survey, like just a question about like telephone access, maybe a question about like whether it's landline or cell phone, right? Because with that, you at a later point, you're gonna be able to get an estimate of that coverage rate, and at a later point, you might consider maybe transitioning your face-to-face survey to a telephone survey if that coverage rate like, is high enough, right? So that's I think what I would say. Okay, sorry. Now I'm got lost. What is the second? What was the second question?
The second question was on can we use RDD to target specific groups?
Oh, good. Yeah, that's a great question. So RDD is the issue about RDD, right? Is that we don't, because we're literally generating random digits, right? We don't have a lot of like information like that we can sometimes have on sampling frames to be able to target certain populations, right? So unless you are able to get some sort of correspondence of area codes or prefix combinations to geographical areas, right? You can use that information to maybe target certain areas. But again, this tends to be better on landline phone numbers than on cell phones, because again, like on cell phones, there's a lot of mobility. So even if there is some sort of like area correspondence, it might not be as good as you would like. But anyhow, like you can use that sort of like geographical correspondence to try to target, for example, certain areas. Now, geographical areas, if you have that information. Other than that, if you have like a geographical information that is narrow enough that you're able, for example, to oversample certain types of groups that are more prevalent in those areas, you can also do that. But honestly, this is very hard. And like, I haven't seen like any good examples in practice of using that efficiently. So that's definitely one disadvantage of telephone surveys, right? Like you don't have as much frame information that you could use to target certain groups. Okay.
Topic
I mean, and I guess you can always do some sort of like screening out, but that's very inefficient. And the third one,
topics which are fit or unfit for
that's another part that I'm going to say, not my area of expertise, right? Like I have like colleagues that are much more experts in this part of like measurement, right? Like on surveys in terms of like interviewer respondent interactions or respondent interactions with IVR, for example. So I mean, even within telephone surveys, right? Like there are almost two different realities, right? Like there is, somebody was mentioning IVR, right? Interactive voice response, and that is more closely related to something like a self-administered questionnaire, more or less. There is some research showing that it's not quite, but compared to a telephone, an interviewer-administered telephone survey, right? Like even like within a telephone survey, you have like this different kind of like modes of data collection that might lead to different response behaviors, right? Like we know that in self-administered modes, those tends to be better to ask more sensitive questions than interview-based modes of data collection, right? Because you don't have like as much of like what we call social desirability happening there when we're answering to an actual other human being. But again, like not exactly my area of expertise on like what are topics that should or should not be asked in a telephone survey. I'm more like a survey statistician. I'm not so much of like a social scientist or like a person, someone who is whose area of expertise like this measurement area. So not gonna answer that much other than that.
Finally, in this round, on the comments regarding the U report.
Yeah, so I haven't heard of that. An interesting approach. So this is almost the way I see it, right? Like almost like those internet polls in a way, right? That like you launch a poll and like whoever is willing to answer that, like answers with the difference that you have like you first kind of like establish this like this list of people who volunteer themselves to be part like of this poll of the survey, and then like you reach back to them. As you may expect, I have several reservations with that sort of approach, right? Because this not only will have several coverage issues, right? Like we know that like not everyone will volunteer their information to be reached out to a survey. It's very likely, I mean, I cannot say like for every possible situation that this was done, but it's very likely that people who volunteer their contact information to be part of this kind of survey or poll are different from those who don't volunteer. So you have there like the two components of coverage bias, right? You have there like very pronounced, right? Like it's probably very small, it has a very small coverage rate and probably a very large difference between those that are covered and uncovered. You have non-response issues as well, but like you have non-response issues like in also high quality RDD or error probability surveys, and probability sampling issues there, right? Like there is no way that you can estimate, that you can compute, not estimate, you can compute selection probabilities. There is a non-probability sample. They're a convenient sample pretty much. So you are kind of like relying on assumptions and models to draw inferences from your population. You're gonna need like, for this kind of thing, you're gonna need to have very powerful predictive variables, very powerful covariates to be able to develop a very strong statistical model to have like estimates that are reliable enough.
Thanks, Raphael. A third set of questions. We still have 9 minutes. Let me start with the following. You mentioned that there's no need for clustering, or clustering is not used in phone surveys. There's no need for it. And you actually sort of referred to possible stratification in telephone surveys. Mm-hmm. Would there be benefits for that one, for stratifying the sample, if we can, during phone surveys? That's one.
Yeah.
Another question, interesting question. Do call centers usually filter out invalid numbers if we are working on lists of phone numbers from call centers? Wouldn't they? Let me change the question a little bit. wouldn't they filter out invalid numbers because they have the phone numbers, for instance? Do we need validation or responses from telephone surveys? Is another question. The other questions are mostly about non-response and waiting. But one interesting question from someone you might know, Sinan actually,
Hi, Sinan.
relates to both terminology and differences. What would be the biggest differences that you would see between phone surveys which rely on sample frames coming from a previous household survey, for instance, like the Mix Plus that you mentioned earlier, or a list of phone numbers which are coming from a registration system of a country, as opposed to RDDs and others. And there was some, if I understand it correctly, there was some concern that Sinan was raising in terms of terminology, because phone surveys are now relating to two different things. One is sometimes it is relating to the whole design of the survey, starting from the selection of the sample, in which case you are selecting phone numbers, but it also refers to the medium of interview or data collection. So the sample frame might be a household survey, but the interview might be conducted on a phone, which is just a replacement of a paper or copy, as opposed to an RDD, which the whole starting point is phone numbers.
Okay. Okay, yeah, that's a great question. So can you just remind me of the first question again, so I can answer in order?
The first question was about stratification.
Oh yeah, certification. Okay, so yeah, great question. Again, so I'm going to refer back to this idea of as long as, so certification with telephone sampling is slightly tricky because usually you need to have, again, the knowledge on how telephone numbers, the telephone system works. Usually you can stratify based on like area code or like sometimes prefix, based on the knowledge of like this correspondence between like the area code and prefix to certain geographical areas. That can be like quite effective in the sense that like as long as there is some sort of like differences between geographies, right, in your target population, you can get some gains in precision. Your estimates can be more precise using that sort of certification, depending, again, of course, depending on the allocation you do of your sample. Like if you allocate your sample, say proportionally, you tend to have like gains in precision if you do that. But again, this will rely on the knowledge of this correspondence between like area codes and prefixes to certain geographical areas. And as I mentioned before, it's even not perfect with cell phone numbers, right? Like it can be helpful, but it's not, have to bear in mind that it's not perfect. With landlines, tend to work better. And also you can stratify, right? Like, I mean, it's not a stratification quite, but like you have like this idea of like landlines frame and cell phone frame. That's some sort of certification. You have that dual problem there that like you need to think on the design or the weighting. And finally, if you have any other information about like how phone numbers are assigned to users, right, other than like geography, sometimes you have that information in terms of like residential and businesses. You can also use that information for either certification, or if you're only using, for example, telephone numbers to reach out to households, to exclude numbers that sequence of telephone numbers that are assigned only to businesses, right? So that's one thing. Second question was about
validation or responses from telephone surveys. Is there a need for that?
Well, so, but what do you mean by validation of? You mean whether the respondent the answers on the survey, or validation of the telephone number that was selected previously? I'm not sure if
Let's assume that it's both.
Okay. I mean, as any survey, right? Like you should, there should be some sort of verification, right? Like I'm sure that for most of the surveys that you guys conduct, you do some sort of verification of the surveys, even if it's face-to-face, right? With telephone surveys, that kind of sort of verification tends to be a little bit more straightforward than something like face-to-face, because usually you have maybe not right now, but typically you have interviewers on some sort of a call center, right, which is a control environment. And a lot of the times, a lot of surveys record some of part of the interviews, so it's easy to do that sort of quality control. And also, you know what's the telephone number that the interviewers are supposed to be calling. You can always like call back that number to verify whether the interviewer actually called that number, whether you can verify also some information. So you should always, definitely should always conduct some sort of validation there, some sort of data quality control. And I think the advantage actually of telephone surveys is that it's a little bit more straightforward, that sort of like verification, than households, than face-to-face surveys.
There was a question on whether call centers filter out invalid numbers.
Oh, that's a great question. Yeah, so I forgot to mention that in most of the cases nowadays, like you don't have actually interviewers hand dialing telephone numbers, right? In most of the cases, you have some sort of like machine, like what they usually call like a dialer or something, that do that process for your staff, and they only redirect the calls that lead to like a working telephone number. It will depend on the machine. I'm not an expert on that, but like that's very typically used. But it also depends on the regulation of the country. So for example, here in the US, you can do that sort of thing. You can use this kind of dialers with landline numbers, but you cannot do with cell phone numbers. So with cell phone numbers, you actually have to have a human being dialing that number, right? So always make sure to check what is the regulation on your country regarding to that, to make sure that you are, you know, like under the law. And if you can, definitely dialers increase the efficiency of the sample by a lot, right? Like you don't have to waste so much of the interviewer's times dialing a bunch of numbers that like will be inactive or not eligible. And Sinan's question, right?
The Sinan's question, but we have only 1 minute.
Okay.
You might even want to postpone to answer to the question to next week. That's also possible.
Yeah, sure. I just like to answer the first question of Sinan, which was,
please.
What was that first question? I really thought it was an interesting point.
Comparing those phone surveys, which are relying on sample frames coming from a previous household survey, as opposed to RDD, and you know.
Right. Yeah. So that's a great point. So the interesting part there is if you're using a previously selected survey, right? Let's say that's a very high quality area probability sampling, right? Sample, and you're using now the telephone numbers that were collected from that survey. The interesting thing is that like all the properties of that high quality survey area probability sample are going to be brought to your telephone survey, right? Because the sample was already selected using that very high quality method, right? So you can bring that to your telephone survey, including those selection probabilities, stratification, clustering. This is something that I was discussing, right? Like with Sinan and Attila the other day, right? The issue there is that you might have some say issues on the sense of like maybe you don't have telephone numbers for your entire sample. Maybe you don't have maybe some of those telephone numbers are not valid anymore. They moved. They don't have that phone number anymore. But the advantage there is that you can still adjust for that using the information that you collected on that area probability sample, right? So you can still do some weighting adjustments, and that's something that we are doing on that data collection that I was mentioning in Brazil with the National Statistics Office. So yeah. That's what I would say. Like, and with RDD, you're starting from scratch, so you have the sort of like potential coverage biases. Not that you wouldn't have, right? Because maybe on your household survey that you previously collected, you might have some people that don't have a telephone access, and you still have that coverage bias now in your telephone survey, right? But you have I think an easier start than starting from scratch on an RDD sample. I'll address the other question either separately or next week, which I think is also a very good question in terms of like the concepts of telephone frame, telephone sampling, etc.
There was a couple of $1 million questions I also suggest we cover next week, which is what exactly do you mean by representative? A representative sample, which we might take up next week. It's a $1 million question, I know. But just to say, Raphael, that lots of questions and good comments came in. So we will share with you all those comments and questions in the chat box, or you might want to have a look at them and maybe respond to some of them next week during next week's webinar.
Mm-hmm.
But at this point, we have run out of time, which is always the case with webinars when it goes so well. Thank you so much again, Raphael, for this great presentation, and thanks everyone for your participation and for the great questions and comments. And I hope to see you all next week at the same time, Wednesday, 8:30 New York time, on the second webinar on telephone surveys. Again, we will have Raphael presenting next week. Thank you very much, everyone. Take care.
Thank you. Let me make a couple of final comments here. One is, never during my presentation, I hope that I use this term representative samples. Those who know me know that I am strongly against the use of such term. I'm gonna address that hopefully next week, and I'd like to just say hi to everyone that I know. I see some of you that send a message here in the chat that know me before. Very good to see and hear from you, and very nice to hear and see from those that I don't know, and looking forward to for some further discussion next week. Thank you very much.
Thank you very much, Raphael. Take care, everyone. Bye-bye.
Bye. See quite a few familiar faces here. Ashraf, Hanyu, Howie, Tuba. This is great. Well, thank you, Attila.
No, my pleasure. I'm still not exiting because I'm waiting for everyone to disconnect, just to make sure that we have the recording in place.
Oh, okay. All right. So then I'm gonna disconnect. We will talk later about this.
Thank you so much.
Next session.
Thank you so much, Raphael. Take care. Bye-bye.
Sure. Bye.